You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall, and if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars, so this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light years long. To give you an idea of how large that is, the Milky Way is only 100,000 light years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew! This is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like 2 drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the 2 bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger, but the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you managed to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory.
Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaitre constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaitre constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between, and these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology, which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi Paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2. But if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi Paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us, because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi Paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi Paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
Let's embark on a wild thought experiment. What if we could magically travel to all our ancestors in chronological order? Could we talk to them and actually form some connection? And just how far back can we go while still connecting with them? Well, let's see. Primates were the funky cousins of other mammals. Around 85 million years ago, during the late Cretaceous period, they went their own way and became the first of their kind. Human evolution is very complicated, and we can't draw a distinctive line on where it started. But we're going to start with hominins. Hominins are a group of primates that include all the species leading up to Homo sapiens. So, imagine you hopped in your super cool time machine and landed in the past, way back when hominins were chilling around. What would happen? First off, you'd spot these quirky creatures roaming around with their short, hairy bodies, curious faces, and big eyes. They might look a bit different from you, but that's part of the fun. They were excellent climbers and incredibly curious about the outer world. They munched on fruits, nuts, and whatever they found in nature. And yes, surprisingly, humans aren't meat eaters by nature. Originally, we all were vegans. Of course, with them, you can forget about proper communication. But still, primates are incredibly smart. So, a good old game of charades could do the trick. Mime your way into their hearts with friendly gestures, and they'll be thrilled to see a futuristic traveler like you. These hominins were curious beings, so they'd probably be very interested in you if you were friendly with them and gave them some food. Next, let's move on to Homo habilis and Homo erectus. Their period, the Stone Age, started about 2.6 million years ago. As you can guess, it was the time when we started using stone tools. The Stone Age lasted for roughly 3.4 million years and ended between 4000 BCE and 2000 BCE. It ended with the beginning of metalworking. Homo habilis, or handyman, was like the MacGyvers of the Stone Age. These crafty creatures were the first to use stone tools. And Homo erectus was the upright man. They were a bit more recent. As their name suggests, they were the first to walk on two legs like us. They might have looked a bit different from modern humans, but still. So what were their lives like? Well, they still were true survivors. Homo erectus loved to explore and tinker with things. They made simple stone tools, like sharp rocks for cutting and scraping. They were basically the early inventors. Homo erectus was quite adventurous. They left Africa and traveled to far-off lands, exploring new territories. They were the first ones to set foot in places like Asia and Europe. They lived in caves or simple shelters made of sticks and animal hides. And let's not forget their wild fashion sense. Animal skins and leaves were their trendy outfits. But don't think they just sat around all day. They were hunters and gatherers, seeking out delicious fruits, nuts, and even hunting animals. How would you communicate with them? Well, they used simple grunts, gestures, and body language to understand each other. So, if you met Homo habilis and Homo erectus, you'd be in for a wild ride. You could show them some advanced technology to impress them and teach them some new cool tricks. Next on our list are Homo heidelbergensis and Neanderthals. Homo heidelbergensis was like the cool older cousin of Neanderthals and us. They lived around 800,000 to 200,000 years ago. Picture them as sturdy and strong, with big brains compared to their earlier relatives. They were expert tool makers and loved exploring new places. The Neanderthals lived in Europe and Asia from 400,000 to 40,000 years ago. Neanderthals were super smart, and they had awesome adaptations to cold weather. With their thick, strong bodies and big noses, they could handle chilly winters like champs. Both Homo heidelbergensis and Neanderthals were skilled hunters and gatherers. They'd chase after mammoths and other big game with sharp spears they crafted themselves. But it wasn't all rough and tough. They knew how to have fun, too. Neanderthals made art and showed their emotions and connections with each other. With these folks, you could draw pictures in the dirt, dance around, and make gestures. They'd get the idea. And finally, we meet Homo sapiens. Picture this. You're waking up in a cave with your family, trying to keep warm by a flickering fire. The cave is pretty cozy, isn't it? But nope, no permanent homes here. You're part of a nomadic tribe, moving wherever the food is best. Hey, but at least you've got some nifty tools to survive. Grab your awesome handmade spear, crafted by watching others or maybe invented by your genius self. Time to go hunting mammoths. And if mammoths aren't cooperating, just gather nuts, berries, and bird eggs. Stone Age humans were real foodies. They made flour from oats and spiced things up with wild onions and mustard seeds. There were artists, too. Using minerals and bones, they created stunning images and even flutes for some musical entertainment around the campfire. You still can only talk in body language and facial expressions. But Homo sapiens were smarter than their ancestors. So you could even teach them basic gestures and their meaning, like hands up for mammoth and stuff. Maybe try doing a funky dance or a happy jig. That would get their attention for sure. But this wouldn't be the only way to communicate. Stone Age peeps loved drawing and making flutes, so you could totally join in on the creative fun. Show off your artistic skills with a drawing or two, or maybe even play some tunes. Don't worry, they would be impressed by your skills, even if you aren't that far away from them. But tools are definitely the way to their hearts. If you brought some handy gadgets or cool inventions from our time, they'd be super impressed. Just create some simple tool from the future that can make their lives easier, and they'll love you instantly. So, while you might not be having deep philosophical debates with the Stone Age crew, you can still share some good times. Learning is the way to go. Besides, even though life was shorter back then, averaging around 30 years, it's still enough time to find a partner and have kids. Though, the dating pool might be a bit limited. so let's leave that topic for another time. Just hold on to that axe at night because, well, sometimes our ancestors would eat each other and like to do some head-dumping battles. Yikes. Let's finish our journey with the Bronze Age, just for fun. This cool era lasted from around 3300 to around 1200 BCE, and guess what? They were all about that strong metal called bronze. It's the time when people got creative and started using bronze to make all sorts of cool things. Bronze is a combo of copper and tin, making it harder and more durable than anything else at the time. Awesome civilizations started popping up all over the place. They either made their own bronze by smelting copper and mixing it with tin, or traded for it with other places. So, as you step into this ancient era, you'll be amazed by the sight of bustling Bronze Age cities with majestic bronze gates, amazing markets, and grand temples dedicated to powerful gods. During the Bronze Age, we finally developed languages and writing. Mesopotamia and Egypt were leading the way with their fancy cuneiform and hieroglyphs, the earliest writing systems ever. They were basically the kings of calligraphy. Remember, the language might be a bit different. You'd be hearing unfamiliar words. But with these humans, you can at least use drawings, art, and many other things to communicate. Anyway, this is what meeting our ancestors would be like. What a wild journey through time. So, remember to cherish our past and appreciate the wonders of our modern world. Stay tuned.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, We can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. there wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path. A white dwarf star, 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi Paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we missed the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila! We have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A, with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974, and we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years, so we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify, but its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
We're in Siberia. It's so cold here that freezing gusts of wind are burning your face. All that white snow seems to be blinding you. This place resembles Antarctica because of the permafrost. Recently, a group of scientists researched one of the local rivers. With the help of a drilling rig, they extracted several samples of frozen soil. The scientists were shocked to find living creatures inside the ice. Later in the laboratory, they realized that the creatures were microscopic multi-celled organisms known as bdelloid rotifers. These creatures looked like little worms. Scientists knew that these worms could live in frozen conditions for up to 10 years. But the age of the rotifers found in the ice was about 24,000 years. And after defrosting, they began to reproduce, as if they had been sleeping for several hours, not thousands of years. Further analysis showed that these organisms could stay frozen for hundreds of thousands of years. The rotifers might have lived during the time when people didn't invent the wheel yet. And this isn't their only superpower. Bdelloid rotifers are among the most radioactively resistant animals on Earth. They can survive in places where there's no oxygen and water. They can also stay alive in areas with high acidity and can live without food and water for a long time. By the way, these are not the only creatures that are known for living for thousands of years. Particular types of moss and some microorganisms are also almost immortal. Nematodes, also called roundworms, are some of the most adaptive varieties of worms in the world. Imagine the Eiffel Tower standing tall and proud. And now, let's make it 10 times higher and place it underground. Exactly at this depth, many thousands of feet under the surface, scientists discovered these creatures. There's no sunlight and almost no air in this place. And since it's much closer to Earth's core than the surface of our planet, the temperature here is higher than in the middle of the hottest desert. Millions of tons of soil above create insane pressure. But all this couldn't prevent life from developing here. When roundworms run out of air, food, or when the temperature becomes too high, they get into a unique state of stasis, or deep hibernation. In this mode, the worm's metabolism slows down, and almost all the processes in their bodies stop. The creatures can sleep for a very long time and only wake up when the environment becomes more livable. By the way, you don't have to go so deep underground to find these creatures. Nematodes are found all over the world. They can live in hot springs, deserts, high in the mountains, among the harsh ices of Antarctica, or inside animals and humans. Our next invulnerable creatures are tardigrades, also known as water bears. These are microscopic, 8-legged invertebrates closely related to arthropods. It's impossible to see them with the unaided eye. But a conventional microscope will allow you to see tardigrades in detail. They look like minuscule bears. They're called water bears because they need a thin layer of water around their bodies at all times. It's necessary to prevent dehydration. Tardigrades have been found in all kinds of environments, from ocean depths to sand dunes. They're incredibly robust thanks to their unique organism structure. Yeah, they look soft, but their body is covered with a tough cuticle. This coating resembles the exoskeletons of grasshoppers, mantises, and many other insects. Water bears shed their old layer of the cuticle when they need to grow. Each of their 8 legs has 4 to 6 claws, which helps them cling to any surface. The bears can survive at a temperature that's almost 3 times as cold as the temperature in the ice of Antarctica. Heat doesn't harm them either. They have been proved to survive at the temperature that makes water boil. Also, water bears are not afraid of radiation and high pressure. In the depths of the ocean, pressure can destroy alloys of the strongest metals, but these creatures can withstand pressures 6 times greater. But the coolest thing is that they can live in the vacuum of space. Our planet has a magnetic field. This is a shield that protects us from solar radiation. Tardigrades don't need this protection. They can go into near-Earth orbit and come back unharmed, all thanks to a protein protecting their DNA from ionizing radiation. Like other immortal organisms, water bears can fall into a state of cryptobiosis. Tardigrades pull their head and legs inside their bodies and fall asleep. If the surrounding conditions suggest freezing, drying out, or experiencing a lack of oxygen, they will remain in this barrel form until the situation improves. So those are microscopic organisms and microbes that can only be seen through a microscope. But how about something bigger? Meet ironclad beetles. They live in the southwestern US and Mexico. These insects cannot survive high temperatures, live without oxygen, or in conditions of increased radiation. But their shells are so tough that they can only be pierced with a drill or hammer. Their durable exoskeletons are made of a special substance, chitin. It can also be found in the armor of crabs or shrimp. And still, the chitin of the ironclad beetle is so durable that it allows this creature to withstand the impact of a car moving at high speed. In times of danger, they can hide their whiskers and strong legs in special recesses in their shell. Other animals can't bite through the armor, so they spit the beetle out and leave to look for lunch somewhere else. As soon as the danger disappears, the bug stretches out its legs again and goes about its business. Also, the armor saves the beetles from dehydration, which is very useful in hot areas of Mexico and the southwestern US. Inside the exoskeleton, they can store moisture. In other words, these bugs can absorb water whenever they find it and transport this liquid inside themselves. The next creatures are incredibly fragile, but they know how to survive in places where almost no other animals can live. We're going to the southeast of Romania, near the Black Sea. Here, on a desolate wide plain, you can notice a pit. This is a mine leading deep underground. The air on the surface of our planet usually contains around 20% oxygen, but in the mine, it's only 10%. Inside the cave, the air also has an increased content of hydrogen sulfide and carbon dioxide. People can't breathe there without an oxygen tank. We can probably say that the water and air there are poisoned. Almost no animals would be able to survive here. Still, 48 species of living organisms have been found in this cave. 33 of them are newly discovered species. And they aren't the only microbes or bacteria that can't be seen without a microscope. Something bigger lives here. Strange white snails crawl over the walls of the mines. Transparent shrimp and a bunch of unknown kind of leeches swim in the water. White centipedes with huge whiskers and creepy white spiders run on the ground. And they all have been growing here for almost 5 million years. You might notice a water scorpion and another unidentified species of this animal. It doesn't look like its relatives living in hot sands or tropical forests. No living creature here looks ordinary at all. All animals are either white or transparent. They have no eyes, but are equipped with long paws and antennae whiskers that help them navigate in this dark space. The deeper you go into the cave, the less oxygen the air contains. But the number of living organisms is increasing. The air is filled with methane and carbon dioxide. All the inhabitants of this cave have never seen the light of the sun and have never gone out of the darkness. It seems impossible to survive in such conditions where plants don't produce oxygen. The answer to the question of their survival is hidden in a small lake. The surface of the water is covered with strange foam. If you look closely, you can see that this white substance is alive. It resembles soft, wet paper that is easy to tear. The thing is billions of living organisms, bacteria called autotrophs. There's much more carbon dioxide in the cave than there is outside, and these bacteria, like plants, absorb it. But they don't do this with the help of photosynthesis, which means they don't need sunlight. They use water for chemosynthesis. What these bacteria secrete is food for other bacteria. And these other bacteria are food for bigger creatures. A unique food cycle that you can't find anywhere else on the planet only exists here.
What makes a giant, well, a giant? You know, big, enormous, you get it. Tough questions. It depends on who you ask. The ancient Greeks had cyclops, while ogres were spread out through all sorts of European folklore tales. The tallest person ever recorded was named Robert Pershing Wadlow, and he lived in the first half of the 20th century. He stood at an incredible 8 feet 11 inches tall, but had many medical issues throughout his life. Sadly, he only lived to celebrate his 22nd birthday. That's because Robert wasn't just tall. He had a condition affecting his human growth hormone, which didn't particularly make his life comfortable. Robert even had to wear leg braces in his adult years. During that same time, incredible discoveries were reported in North America. Some people claim to have uncovered weird-looking skeletons, much larger than previously associated with human beings. It immediately raised the question, did giants really used to roam our planet? Our story begins with the idea of a mound builder race. Some scientists back in the day claimed that these massive earthworks in places like the Mississippi Valley, called the Grave Creek Mound or the Great Serpent Mound, were built by some sort of prehistoric type of human, much larger and stronger than us Homo sapiens are today. From around 1812 to the 1860s, almost everyone in America writing about history was covering this mound-building race. However, not everyone agreed with the theory. There was this naturalist named Benjamin Smith Barton, for example, who warned about jumping to conclusions about giants. He believed that just because people discovered some big bones, they shouldn't immediately think of giants. But people didn't listen. Really? They simply wanted to believe about huge human-like creatures, despite not having any real scientific evidence. Newspapers were filled with these giant stories. They described finding giant skeletons, even featuring weird body parts. Con artists took advantage of the whole frenzy, with some putting together skeletons out of wood and rawhide and touring them as proof of the long-lost race of giants. Eventually, in the 1930s, an anthropologist from the Smithsonian took it upon himself to debunk the whole mystery. And his conclusions were straightforward. All those giant skeletons that were supposedly uncovered were either hoaxes or simply animal bones that were wrongly identified as belonging to humans. He also said that those who claimed to have discovered ancient giant remains were just not that good with human anatomy. You would think that's how the story ended. Well, it didn't. You see, people became so convinced that giants existed that they simply could not let go. Sound familiar? Because the Smithsonian was investigating these claims, some people started thinking they were up to something shady. They cooked up this theory that the Smithsonian scientists were secretly getting rid of giant bones to hide the truth about giants. This whole story survived through the years and made it all the way to 2014. Is when this internet article said that the Smithsonian used to have tons of giant skeletons but destroyed them back in the early 1900s. And the drama continued. A famed publication even looked into the past of some of those Smithsonian scholars to try and pick apart their credibility. So the institute had to do some damage control. They've since added new people on the team whose job is to figure out if those bones were correctly collected and studied. Now, it wasn't just North Americans that claimed to have stumbled upon giants. The French had their own discoveries too. Their story takes us back to 1890, when an anthropologist was digging around a Bronze Age site in Castelnau, France. What he found were 3 bone pieces that looked like they came from a giant human. The findings included a massive thigh bone, a shin bone, and a regular upper arm bone known as a humerus. Now, if we put all these bones together and calculate the proportions, they lead us to this towering figure, somewhere between 10 and 11 feet tall. However, in 2022, contemporary scientists took another look at those bones. They concluded they most likely belonged to a cave bear, not a human. It wasn't that unusual for people back in the day to confuse giant animal bones with those of humans. Now, the truth is, our ancestors were in fact taller than we are today, despite them not being technically giants. The average human body has changed a lot over thousands of years. We're not as big and strong as our ancestors were. In fact, we've been on a bit of a downsizing trend, especially in the last 10,000 years, and it's because of a mix of factors. Our genes, the world around us, and how we live our lives all play a role. Way back around 40,000 years ago, European men were towering at around 6 feet. They had a seriously tough life, though, hunting and gathering all day. That lifestyle required a good muscle structure, and their African roots might have given them that extra height, which came in handy in warm climates. Moving on to 10,000 years ago, we can already see a big change in European males. They went down to 5 feet 4 inches on average. What happened was the climate was shifting, and people were increasingly relying on agriculture to provide for their families. It wasn't all sunshine and comfort, though. Sometimes failed crops and a not-so-diverse food meant a pretty unhealthy diet. Plus, being around farm animals more and more introduced some new medical issues to the mix. We're now around 600 years ago when the shortness continued. And yes, we can still blame it on poor diet and health. However, there seems to be a change in recent years. Today, European males are reaching an average of 5 feet 9 inches. And sure, the fact that we're eating more veggies and getting regular checkups at the doctor did help a lot. But it's also because of industrialization and living in cities. This has brought people from different backgrounds together, which is a good thing. It decreases the chances of human passing on genes that could cause problems. So, it's a combination of better living and genetics that's making us taller. We shouldn't give up on ancient giants quite yet, though. You see, experts believe they recently discovered the remains of such a person who supposedly lived in ancient Egypt. Sometimes people can actually grow to large sizes due to a condition called gigantism, the same that made Robert Pershing Wadlow grow to such an impressive height. When some archaeologists were studying ancient Egyptian mummies, they came upon an interesting skeleton. What made it special was that they believed it might have belonged to a pharaoh, who would have been really tall, like 6 feet 6 inches tall. To put that in perspective, that's way taller than Ramses II, who was the tallest recorded Egyptian pharaoh and stood at about 5 feet 9 inches. These experts took a closer look at the newly found bones, especially the long ones, and found evidence of something called exuberant growth, which basically means this person's growth was off the charts. It's a clear sign of gigantism, they say. Now, this discovery is important because it makes this mummy the oldest case of gigantism in the world. No other Egyptian pharaohs were known to be giants. It's also fascinating because it tells us something about the health and nutrition of ancient Egyptian rulers. See, those pharaohs were probably better fed and healthier than regular people. which might explain why they could grow taller than the average person. Now, you might be wondering if being a giant had any drawbacks back then. Well, it's hard to say. I wasn't around then. Still, during those early dynasties in Egypt, they seemed to prefer shorter people, especially in royal service. There are a lot of ancient Egyptian stories featuring short-statured leaders and even higher spirits that locals looked up to. The reason why is still a mystery that we might never fully solve. But since this mummy was found in an elite tomb, it's possible that being a giant didn't have a social stigma attached to it at the time. Maybe he was, in fact, seen as special. If you were to look at Earth from the International Space Station at night, you'd be able to see the lights of the cities from space. That's how big our impact as a species is. There are huge multicultural cities all around the world. We've built buildings so high they nearly disappear out of sight. Cities built from the ground up for thousands and thousands of people to live in. But oh, what's this? What a beautiful monkey! What are you doing there, buddy? You want that banana? Yeah, it looks delicious. Be careful now, don't fall down that tree. Oops. Boy, nature can be so brutal sometimes. I'll bet it didn't wake up thinking it was going to become a lion's breakfast. What? No humans? Where did they all go? Looks like when that monkey fell from the tree, it created a chain of events that led to no humans ever existing on Earth. I know what this is. We must be in an alternate universe. Well, let's skip a few thousand years ahead. What does Earth look like? Humans have altered about 50% or more of the planet's surface. So there aren't going to be any cities or landscape previously shaped by us in this reality. There's not going to be a human touch at all. The Earth now seems to be an animal paradise. They're everywhere. These animals that were previously only found in Africa are now all over different continents. There are lions roaming free in America. Oh, and look, in Europe, there are rhinos, elephants, wolves. Wow, moose. Even bears are here. Since there are no humans taking up most of Earth's space, mammals are now free to be everywhere. Well, you know, different mammals than us. There's a huge diversity of them too. Earth has become what seems to be an expansion of the Africa we know today in terms of animal species. You can see large mammals too. Giant sloths, saber-tooths, and even mastodons are now walking the Earth like in the olden times. The reason why our Earth isn't like this is that humans take up a lot of the available space with their structures. For example, the reason why there's so much animal diversity in Africa in our universe isn't that the continent is just suited for animals to thrive. It's mostly because we haven't been too active in a big part of the continent. Our ancestors had a lot to do with the extinction of large mammals. Ice Age wasn't the only culprit there. On our Earth, humans are the intelligent life form. How about on this planet? As you might know, natural selection is what guides evolution. This, combined with random mutations we can observe in some species, suggests that even without humans on Earth, there's a chance for intelligent life to develop. So, primates are now the dominant life form, or maybe the meerkats evolved into a dominant species. The climate on this Earth is also cooler than ours. That's because there are no greenhouse gases. According to NASA, the current Earth warming trend is likely the result of human activity since the 1950s. This means the increased levels of greenhouse gases in the atmosphere are the reason why our planet warms up. Greenhouse gases are called like this because, just like a greenhouse, they trap the heat. They let sunlight pass through the atmosphere, but the heat it brings doesn't leave our atmosphere because of them. They're a good thing because otherwise life on Earth wouldn't even be possible. But because now they're too abundant, it causes the planet to warm more than it should. Now, let's go back to our alternate Earth. In the water, the Great Barrier Reef in Australia is still fully intact. And it's still the largest coral reef system there is, as well as the biggest living organism on the planet, just like ours. This new Earth is also full of trees, and lush ones at that. Greenery everywhere. All sorts of trees exist and are home to all the different animals on the planet. And since there's no deforestation, The planet's lungs, the Amazon rainforest, is able to thrive and is looking more alive and vibrant than ever. But say, what if humans were to show up on this Earth right now? Maybe this year, or the year before? They certainly wouldn't be the dominant species immediately, and would probably struggle at the very beginning. The evolution and learning process would be a slow one until they find themselves at the top. They have to adapt to their new home. This would be like traveling to around 130,000 years ago in our reality, to a place where modern humans, or Homo sapiens, had just shown up. Humans back then weren't new. The only new thing about them was that they evolved into Homo sapiens. It wasn't like we were dropped off from a spaceship onto Earth or anything like that. But in this alternative reality, that's exactly what happened. A bunch of humans were dropped from the sky on Earth. Now, they must learn everything from the ground up. They need to figure out how to survive and thrive in their new environment. They have to hunt for their own food, and they need to take what they can from the planet, much like we did 130,000 years ago. These new humans are nomads. They can't settle in one exact place because they need to explore and understand their surroundings, just like the animals that surround them. As their groups become larger, they split into smaller ones to find new places suited to build their homes, or even a place where survival might be easier. Since it's been a while that they've arrived on this new Earth, they've done some exploring and found themselves more comfortable in their new setting. Their tools are better developed, and home-like structures, like huts, finally start appearing. 50,000 years ago, we developed our language. These humans also developed their own because they need to communicate better with each other. With language, they become more and more organized and are able to make better plans for their future. All dogs come from wolves, and there are two theories of how it might have happened that wild beasts became humans' best friends. One theory says early humans somehow ended up capturing wolf pups and kept them as pets, and over time they would gradually domesticate wolves. Another theory states that wolves actually domesticated themselves. It's called survival of the friendliest. Because both wolves and humans were hunters, wolves probably also figured out they would have benefits if they stuck around humans instead of competing directly with them. Some wolves were fearful and aggressive toward humans. Others might have been friendlier, which also likely gave them access to the hunter's food supplies. As time passes, modern human behavior starts showing up. Fixed homes begin to appear in places that benefit people, maybe next to a river or places where the soil is fertile. This way, they're also able to become farmers and develop agriculture. As they settle down, communities start arising too. Since they are very social beings, it's only natural they're drawn to one another. Soon humans are all over the planet, spread around the continents, with communities and families of their own, and don't forget the pets. The planet's landscape shifts like it did in our reality, to accommodate the needs of humans. Cultures are developed, rivalry begins, they start pushing each other to great lengths. Thousands and thousands more years go by, and this human society starts to look a lot like the one we have today. Still, things might have happened a different way. There might have already been an intelligent species they would have had to compete with, and then their progress would probably have staggered a bit. Maybe a society could emerge where different intelligent life forms would be able to peacefully coexist. When you enter a coffee shop, a meerkat might be your barista. Your landlords could be a couple of gorilla siblings. Or when you go to a barber shop, a primate that's only wearing a barber jacket would be the one to cut your hair. If not, it's likely things would end up the same as our reality. Humans would not be the most numerous species on Earth, but they would certainly still be the most impactful one.